Hi, this is Mark with Ivy Scholastic, and thank you all for the positive feedback and comments you've given me. Today we're going to go ahead and continue our quest through the first test of the Blue Book, and now we're going to go on to section 7, which is the second math section that we have in the first test. So the first question asks, the pictogram above shows the number of new homes built in Cityville for each of 4 different time periods from 1961 through 2000. How many new homes were built from 1961 through 1990? Keyword is through. So it basically means if this were a timeline, and here's 1990, and let's see, it starts off in what, 1961? It's like it's a solid dot, means it includes that year and goes all the way up and includes the year 1990. After that, 1991 to 2000, we don't include. So I already drew out the relevant portions here. And this is a question number 1. So we don't want to berate it too much, but so you could just count these up and multiply by 2000, which is how much each home represents. But just a quick little observation that'll help for more advanced pictogram problems that can sometimes appear later in a section. You'll notice that these clump in 2 clusters of 4 for 8, plus this cluster of 4, plus that. So we got 8 plus 4 plus 2 is 14, and then that is what we can multiply by 2000. Let's look at these first digits here. We get 28, add 3 zeros, and the answer is E, 28,000. Sometimes the SAT gives you pictogram problems that have a little bit more complicated counting and some twist to them. So that's why I like to kind of point out some of these kind of quick ways to look at the pictogram. Okay. Number 2, what is the value of W in the figure above? All right, and one thing I want to point out is that opposite angles are equal. So just imagine a Cartesian plane somewhere, and imagine that 2 non-parallel lines are just somewhere out in outer space, and they're on a flat plane. If they're not parallel, they will inevitably meet on that flat plane, and when they do, their opposite angles, like this, are always going to be equal, and same for those. So we're going to apply that concept here. Look at that. Oh, we got these opposite angles here, and we got these opposite angles here. Now check this out. Whenever you have a triangle on the SAT and you know 2 of the angles, you usually are going to have to utilize the fact that all the interior angles of a triangle add up to 180 degrees. So in other words, W plus 45 plus 35 is going to add up to 180. And that's going to solve our question for us. Okay, so you can just subtract off each one of these minus the 45, and then we're going to get 100 here, and that is answer choice B. Okay, so don't forget, the sum of the interior angles of a triangle add up to 180. That shows up quite a bit in these problems. So number 3, a restaurant has 19 tables that can seat a total of 84 people. Some of the tables seat 4 people and the others seat 5 people. How many tables seat 5 people? All right, so I wrote out the basic figures from this problem. This is the kind of question that you can turn into an equation with 2 unknowns. So we have 4 tables that seat, we have some tables that seat 4 people. I'll just give it a variable, say S. I imagine it's a small table. And then if you add on that there are 5 other tables that seat 5 people, I'll just think of them as big tables, so I'll give it the variable B. Then all of this together, if you take all the tables that seat 4 and all the tables that seat 5, it ends up adding up to what they give us right here, 84. Okay, so whatever number of small tables there are, whatever number of big tables there are, once we add them up and multiply by how many are seated at each one, this is how many people total there can be in the restaurant. Okay, so the next thing is that there are a total of 19 tables. That means if you took all the small tables and added them to all the big tables, you would have a total of 19. Well, we now have a system of two equations. So a system of two equations. And we have two unknowns, S and B, in this system of two equations. So the rule in general is that if you have some system of equations and you have the same number of equations as you have unknowns, you can solve for any of the unknowns by plugging in one equation into the other so that you get something all in terms of just one variable. So over here, so they're interested in which one? The big tables, the 5-seaters. So I'm just going to go ahead and go small table equals, and I'm going to subtract b from both sides, 19 minus b. I'm going to take this little puzzle piece and I want to plug it in right to here. So this is going to produce 4 times 19 minus b plus 5b equals 84. Oh, I didn't even notice I had my little color palette out there. Okay, so here we can go ahead and go to the, if you want, you can pull out your calculator. 4 times 19, we're going to get a 76 minus 4b plus 5b equals 84. You'll notice that if we collect like terms, and negative 4b plus 5b is just b. So we have a 76 here plus b from these two. So these have summed up to just b equals the 84. I'm running out of room, but I'm going to subtract 76 from both sides. I'm going to get 8. All right, so b is going to equal 8. So I'm going to write it up here. Okay, so b equals 8. All right, let's look at our answer choices, and indeed, number 3, E is 8. All right, so let's go on to the next one. On to the next one. Number 4, if a equals 4, which of the following is equivalent to am squared plus am plus a? So let's go ahead and actually plug in what the information they're giving us. So we're going to have a 4m squared plus 4m plus 4. Now you'll notice whenever the leading coefficients on these variables and this so-called loose term are all the same, you can factor out that number. So we can have a 4 multiplied by an m squared plus an m, be careful here, plus a 1. I notice some students will accidentally write a 4 there, so just be careful. So we factored out that 4, and it's an equivalent expression. And when we look at our answer choices, this actually matches up just right with answer choice D. And the other ones, if you distribute the 4s through the parentheses, you'll see that you'll never get a result that boils down to this. Okay, so even if you didn't maybe get to this right away, once you start playing with the other answer choices, you'll see that they don't work out. All right, so now let's go ahead. Go on to the next one here. Number 5. In the figure above, the circle with center O is inscribed in square ABCD. What is the area of the shaded portion of the circle? All right, so let's think a little bit about just the area of a circle in general first. Let's just think about that, the whole thing. The whole pizza pie. That thing's area is pi r squared, right? If the whole thing is pi r squared, of a circle, then what would some fraction of it be? Let's think in terms of that. So let's say, okay, I'm going to eat this chunk over here. And let's say that, now this is a separate problem, by the way, I'm just illustrating the concept. Let's say that this were a 90-degree angle in there, and there are a total of 360 degrees in the circle. Well, what is 90 out of 360? If you ate 93/160ths of the pizza, you've actually eaten 1/4 of the pizza. All right, and you can double check that on your calculator. You can go 90 divided by 360, and you'll get your 0.25, which is the same as 1 divided by 4. If you want to, I know some people like the comfort of double checking that all of this is actually true. So this circle it says is inscribed in the square ABCD. Because it's inscribed in the square, we see, and that the center is O, we can understand that this chunk here, the fact that this shaded area is made up of these lines that connect the corners with the center, we understand that this shaded region is 1/4 of the entire circle. So it's actually analogous to the situation we have down here. We also have this value of 2. Be very careful with that value. That 2 lines up, it's the length of the side of the square, so it's 2 all around. Let me scratch that out so there's no confusion. It's 2 all around. So that means from here all the way across the circle to there is a distance of 2, but that's the diameter. Remember that the area formula is asking for radius, so you want to cut that 2 in half, and there the radius is 1. So let's just find the area of the whole thing. The area of the whole thing, we plug in a 1, and the area of this whole circle is 1. Is 1 times pi, so it's just pi. All right, just to make it clear, we've got pi multiplied by the radius squared equals just pi times 1. Okay, we've already said that this is 1/4 of the area, so 1/4 of pi equals pi over 4. Let's look at our answer choices, and that is indeed answer choice A. All right. So this is, when you have things inscribed inside of squares, remember that a sector that's defined by these legs connecting a corner of the square to the center will be 1/4 of the overall area there, of the overall area of this circle. Okay, number 6 here. In the xy plane above, the equation of line L is x plus 3y equals 12. Let me write that out here. X plus 3y equals 12. Okay, which of the following is an equation of a line that is perpendicular to line L? So we're going to have to talk about 2 concepts here. The first one is the equation for a line. Go ahead and recall that it's y equals mx plus b. This is our equation for a line, where m is the slope and b is the y-intercept. Y-intercept is a fancy term for when does this thing hit the y-axis. All right, in this case, right there. Line L hits this guy right at that spot there. Slope is how slanty, right? How slanty a line is, and is more formally defined as the rise over the run. So how much the y values change in the line divided by how much the x values change, okay? So whenever you're given a formula that the SAT writers tell you, hey, this is the equation of a line, you want to put it in that form. In this case, that means we have to isolate this y variable like it's shown here. Okay, so let's go ahead and take this. We're going to subtract x from both sides. We're going to have 3y equals 12 minus x. And then we're going to divide this 3. And be sure you divide all the values over here by that 3. You don't want to just make the mistake of just dividing by 1. Okay, so the 3's over here cancel out. By cancel out, let's just quickly think about this. Any number divided by itself is equal to 1. 3 divided by 3, therefore, is also equal to 1. It's a number divided by itself. 1 times this y is just y. So I notice some teachers will say the phrase cancel out for things like this. Some number minus another number equals 0. And so I've actually noticed some students actually get confused because cancels out to them can mean 0 or it can mean 1. All right, so in this case, I just want to be ultra clear that cancels out means 3 divided by 3 equals 1, and 1 times y is just y. All right, so let me remove this. So y then equals, now what's 12 over 3? 4 times 3 is 12, so we're going to put a 4 here. 4, and then we're going to have a minus x over 3, or I like to just write it as 1/3 x. Same thing. All right, we do a little bit of rearranging so that it looks exactly like this, and we'll have y equals negative 1/3 x plus 4. Now I'm looking over here. You don't want to jump to the answer choice. Okay, they didn't put a trick answer choice for this. They usually have They usually have a trick answer choice to catch you if you stop there. But this time they didn't do that, did they? No. So the second concept we have to discuss is what it means when something is perpendicular, when one line is perpendicular to another line. So this line L, so this is the y of line L, has a slope of negative 1/3. A line perpendicular to line L, this is a symbol for perpendicular. You don't have to remember this. This is just a little formality. A line perpendicular to line L is going to have a slope, in other words, this m value, will have a slope that is the negative reciprocal of this line. I think that bears repeating. So whenever a line is perpendicular to another line, this line's slope is the negative reciprocal. Actually, either line's slope is the negative reciprocal of the other. So what does that really mean? So negative 1/3, its reciprocal just means let's flip the guy. Let's take the numerator and denominator, let it switch places. So here's the reciprocal, negative 3/1, or just negative 3. Now let's take the negative reciprocal. Be careful, we have a negative of a negative reciprocal, which is positive. So this becomes positive 3. All right, so the line that's perpendicular to this thing is going to have a 3x there. And we don't know it's, let's see, do we know it's y? Let's see, line is perpendicular. Which of the following is an equation of a line that is perpendicular? So there's only one answer choice that has a slope of 3, and that's answer choice C, and we can stop there. Okay, so if you have to find the y-intercept ever, you usually need to plug in a point. Like it'll tell you a line that's perpendicular to this passes through the origin, which is 0.00, or it passes through 0.33 or something like that. Whenever you get that point, say it's the origin, you need to just remember, hey, this is an x-y coordinate pair. For this problem, by the way, we're done. Just to make that clear, we're done with this problem. Go on if you're actually on the test. But the SAT writers recycle this kind of problem a lot, where the perpendicular line is passing through either the origin or through some other point. Then you just need to plug in a 0 for y and a 0 for x. And okay, I just realized the origin is a bad example. Let's say it's 3, 3. Plug in a 3 for y, and then you plug in a 3 for x, and then you say plus b for, see, as you can see here, plus b is the y-intercept, and then you solve for b. And in this case, b would be negative 6. And then the final equation of the line perpendicular, this is not number 6. This is a theoretical problem. Line perpendicular to this one would then be 3x minus 6. All right, so you just want to plug in for that. I stopped using the origin as an example because you plug in a 0 for y, you plug in a 0 for x, and you're done. And the y-intercept is just, it's like saying plus 0 out there, which you don't write. So this would be the final form. Okay, that's number 6. Now let's go ahead and go on to number 7 here. Two sides of a triangle each have length 5. So I already drew that part out. All of the following could be the length of the third side except. Now I went and found a website that will help us illustrate this, but this is testing something called the triangle inequality. And the triangle inequality says that whenever you have any triangle, that the sum of two of the sides, a plus b, must be greater than the length of the third side. Likewise, that third side, by the way, you could designate any side as a third side, is going to be greater than a minus b. So a way to generalize this is to say the sum of any two sides of the triangle is greater than the third side, and the length of any part of the triangle is greater than the difference between the other two sides. Okay, so now I found the website. Let's see if I can get it to pop up correctly here. Yeah, here we go. That'll illustrate this. So here comes a broken triangle, and I'm going to go ahead, see, we can move this triangle's legs around here. I'm going to go ahead and do what the problem says. I'm going to make two of the sides equal to 5. And now let's look at this third side. You see, if it's here, this shape that we have definitely breaks a triangle inequality law. As you can see, the third side here, this C thing that's trying to connect to B, this chunk here is way bigger than the sum of the other two sides. And this is what results. Now, 5 minus 5 is 0. So that is pretty clear. That's not going to make a triangle. We could at best make this become a line of some, maybe and we don't even have a triangle anymore. But anything greater than 0 at all, that at first might not look like it'll work, but it can once we go ahead and take the time to connect those dots there. And so 1, 2, 3, 4, anything less than 10, we can make work by arranging the triangle around. All right, so this is all just to visually prove the triangle inequality. I don't like just asking people to memorize math. I think it's good to know why these rules exist. So answer choice E is let's actually demonstrate. It's kind of hard to see on here, but you can see as we get to 10, this isn't going to work anymore. And more than 10, more than the sum of the other two sides, we're definitely breaking the rules. 10 can be kind of hard to see because maybe you could sort of arrange it, but you could still see that it's breaking the rules there. It's just overshooting it. We can go far back, and now this is why I was almost hesitant to show it on this application, but if we really zoom in, you can see that it's shooting past. But at 10 itself, it can be kind of hard to see. But I hope that still proves, though, that this is good enough of a demonstration of what we're talking about here. So 5 minus 5 is 0 for the A minus B part. 5 plus 5 is 10. Anything in between, not including, but in between 0 and 10 will work. So 1, 3, 4, square root of 50. I think they want that to be a red herring there. The approximately 7.07, the answer choice pops out, so people want to circle that. But it is, in fact, E, 10. All right, now we'll go to number 8. And oh no, it zoomed in. So number 8. Now, we're on the last question of the section here, of the mini section. So after this, it goes on to free response. But the last handful of questions in the sort of mini section within the overall section, those last few questions are tough. So if something is overly obvious or seems like a super obvious response, you want to go ahead and really be careful that you're not being tricked. Okay, number 8. In an election, 2.8 million votes were cast, and each vote was for either candidate 1 or candidate 2. So if we add up all the votes both of them got, we're going to come out with 2.8 million. All right, candidate 1 received 28,000 more votes than candidate 2. So candidate 1 had the same number of votes here, but plus an extra 28,000. What percent of the 2.8 million votes were cast for candidate 1? So the percent part means we need to find candidate 1's actual number of votes that candidate 1 got, put that number over 2.8 million, and then we're going to convert the decimal we get to a percent. So if you notice, this is a system of two equations. And just like on number 3, we have two unknowns, which is candidates 1 and 2, number of votes, and we have two equations. So that means we can solve by plugging one of the equations into the other. So here we have the variable Roman numeral I to stand for, the number of votes the candidate 1 got. And we're going to plug in this whole bit here into there. And we're going to end up finding how many votes candidate 2 got, which will then lead to us finding how many votes candidate 1 got. All right, so let me just rewrite down here. Instead of just I, we're going to put in its equivalent, which is candidate 2 plus 28 grand plus candidate 2 again. By the way, that came from right up here, just rewriting, equals to 2.8 million. All right, and so we combine like terms. That is 2 times candidate 2 equals, I'm going to subtract off this 28,000 minus 28,000 is going to equal 2.8 million minus 28,000. If you need, go ahead and go to here. I already plugged in the relevant numbers. We have, this is going to be equal to, let's see, what is this number? 2,772,000, right? We're going to go ahead and divide by 2. I already stuck that on my calculator so that I could just quickly say that this is 1,386,000. Okay, now we got one of the unknowns. Anytime you have a system of two equations and two unknowns, you can then take the unknown that has become known and stick it into either of the equations. This one is nicer because I didn't like typing out 2.8 million in my calculator very much. So we'll just stick that in, add 28 grand to it, and we have that this candidate 1 received 1,414,000 votes. Okay, now we're not quite done yet. Percent means out of 100. So we got to set this up like this. We got 1,414,000 all over 2.8 million is equal to what percent of 100? Okay, so if we take the 1,414,000 divided by 2.8 million, so I got to be really careful with the number of zeros. I'm going to get 0.505. 0.505 equals percent out of 100, multiply both sides by 100, and you get 50.5%. And let's see, that would be answer choice C. So answer choice C is our answer for this. All right, the other way is just to understand that once you get down to the 0.505, you just go, okay, I move that decimal point over 2 times to the right, 50.5, and then you can immediately circle the answer. Okay, so let's go ahead and go on. So now that we've jumped to number 9, we are actually starting a new mini section, in this, so to speak. There's always one section on the SAT, at least before they revise it in 2016, right? There's always at least one section on it that is divided between multiple choice and free response. The multiple choice part is arranged in general from least to most difficulty, and then that sort of difficulty counter resets for the free response. So now you start off again at the more elementary questions and then work on up as you go later into the free response section to the tough ones. Okay, so let's look at this one. If the square root of 2p equals the square root of 18, what is the value of p? So what I'm going to do is I'm just going to go ahead and square both sides to get rid of the radical. And we're going to have 2p equals 18, and then we're going to have p equals 9. And that will be our answer. All right, let's go ahead and do number 10. All right, when 1.783, get my pen out, when 1.783 is rounded to the nearest whole number, the result is how much greater than when 1.783 is rounded to the nearest tenth. All right, so for whole number, that's an integer. So we're going to look at this value, and we see the general rule for rounding is that if it's a 5 or greater, this thing rounds up. If it's less than 5, so 4, 3, 2, 1, 0, then this will stay the same. So this is greater than 5, so the nearest whole number is 2. The tenth, so here's the tenths place, hundredths place, thousandths place. So we're going to do the same process, but we're going to look at this. That's also greater than 5, so this is 1.8. And it wants to know the difference between those two values, and the answer is 0.2. So now we're going to go ahead, let's see, do I have number 11? Yes, I do. I already have it written out. Samantha is, it says, number 11, Samantha is packing for a trip. Of the towels in the closet, 6 are brown. She will randomly pick one of the towels to pack. If the probability is 2 out of 5 that the towel she will pack is brown, how many towels are in the closet? Okay. So in other words, here, my pen went away. There's some total, I'll use T for some total number of towels in the closet, which is what they want to know. If the probability of getting a brown one is 2 out of 5, that means 2/5 of the towels in this closet are brown. That literally means then, as you are, going and picking out randomly selecting one towel, if the chance is 2 out of 5 that it's brown, that means out of the complete total number of towels in there, 2/5 are brown. That's what mathematically this is interpreting. All right, and they already told us how many towels are brown, and that's 6. So 2/5 of the total is equal to 6. Now let's go ahead and the way to eliminate cancel out here, that phrase cancel out comes back again. The way to cancel out a fraction is to multiply by its reciprocal, which just means flipping it upside down, square numerator and denominator switch, and then just multiplying. So 5 divided by 5 is 1, 2 divided by 2 is 1, 1 divided by t is simply t, so t is all by itself now. 6 times 5 is 30, because we're just going to, remember, this is a whole number. It's just like saying 6 over 1, so when we multiply fractions, we're just going to multiply straight across the numerator, straight across the denominator. 6 times 5 is 30, 1 times 2 is 2, and so the final answer is 15. So number 11 is 15. Okay, and it looks like I already have number 12 written down. So number 12, 5 different points, A, B, C, D, and E, lie on a line in that order. The length of AD is 4.5, and I already have that drawn here. And the length of BE is 3.5. And if the length of CD is 2, what is one possible value for the length of BC? And they want to know this interval right here, BC. When you have these number line word problems, I find it helpful to draw them out like this. And then for this one in particular, we'll start reasoning through it. So we know that AD, this whole length, AD, ooh, I better not draw it down that low, I'll run out of room. AD equals CD plus BC plus AB. All right, so we'll just go ahead and write down. Now CD is just 2 plus BC, line segment. Let me make it clear that these are line segments, not variables being multiplied together, plus AB. We know that AD is in fact 4.5. So we can go ahead and scratch that out. And so 4.5 minus 2, because we're subtracting 2 from both sides, is equal to 2.5. So this becomes 2.5 is going to be equal to the value we want that we're looking for plus AB. Okay, so that part's done. Now let's look at this over here. BE in total is 3.5. So BE equals 3.5. And that's going to be equal to BC, which is what value, the mystery value, plus CD, which is 2, that's given, plus DE. Right? We're going to do the same trick over here, subtract 2 from both sides. We're going to have then 1.5 is equal to BC plus DE. Okay, now let's reason through this question. Because these are all chunks of line segment, and because these points are all in a row, we know that there cannot be any value that is 0 or less. Right? We can't have a negative distance, except perhaps in a science fiction novel, where maybe you start traveling faster than the speed of light or something like that, and you start, I don't know, making space do crazy things. But for the SAT, we can't have a negative length, okay? And it's not going to be 0 either, or otherwise the two adjacent points would just collapse to a single point. So we know that AB, that all these line segments are at least are greater than 0. All right, so we know that DE has to be greater than 0. It could be infinitely close to 0, but never quite 0. So let's subtract off DE as like a 0 point whole, imagine a huge number of zeros, basically something really, really close to DE from this. And we're essentially saying that BC has to be less than that. Right? So BC has to be less than something, not if it were equal to that, if it were equal to 1.5, then this wouldn't be some infinitesimally small value, wouldn't be subtracted off of it. So BC is not less than or equal, it's just less than 1.5 over here. It's also based on this information, let's see, over here. We subtract off that AB. We don't know what AB is. They didn't tell us, but we know it's greater than 0. So we subtracted something greater than 0 from this. We know that BC then also has to be less than 2.5. Well, 1.5 is more relevant. It being less than 1.5 takes care of it being less than 2.5, right? So therefore, BC is, you can grid in any answer choice between 1.5 and 0, because you know that BC, we just said, has to be greater than 0, but it can't be bigger than 1.5. If it is, then this isn't going to work out anymore. All right, so if we put, let's just prove it. Let's say BC is, let's say it's 1.6. All right, BC is 1.6 now. Then this, this is equal to now 3.6, and we're adding on something greater than 0. So let's just say 0.1 for the fun of it. Now it's 3.7. That's not 3.5. It doesn't work. Or let's give it a value of 2. So in this case, if BC were 2, and we wanted to find, let's say we wanted to find DE, oh dear, DE is going to be negative 0.5. And again, I mean, that is a cool concept if you're writing science fiction, not for the SAT. So anyways, you can grid in any of these values. You just grid in a 1, for instance, it'll work. Okay, so let's go on to number 13. All right, so let's see, number 13, we have, in the 30-day month of April, for every 3 days it rained, there were 2 days it did not rain. Okay, the number of days in April on which it rained was how much greater than the number of days on which it did not rain? All right, so basically, if there are, every 3 days it rains, there are 2 in which it doesn't. So we got 3 days of rain. Let's see, 2 days of sun. All right, let's just say sun. 2 days of other is going to equal 30. So when I look at this, I think, look, these are units of 5 days. Think about that, right? We got 3 rainy plus 2 sunny. 3 plus 2 is 5. All right, so there are sort of 5 units of these 3 plus 2 chunks. All right, and then how many times does 5 go into 30? Well, 6. Well, so there are 6 chunks of this kind of weather. So in other words, 6 times 3 from here is going to give us how many rainy days there are. So there's 18 days of rain. And then, alas, only 6 times 2, 12 days of non-rain, all right, or sun. I'm kind of wanting to call it sun, but it's not non-rain. All right, and the difference between the two is indeed 6. And that's our final answer. Now, there's another way of doing this. So if you don't like this idea of sort of thinking, hey, let's break this down into chunks like I did just now, you can turn it into a fraction. So for instance, you could say, okay, this means that 3/5 of the total number of days, which is 30, are going to be rainy. Right? And then you can go right to your calculator, go ahead and go 3/5 times 30, and indeed you'll get 18. And then this part means that 2/5 of the total number of days are going to be non-rainy. And I want to at least write sunny one time, just for the fun of it, because we've had a lot of rain over here where I'm at. So divided by 5, all right, and that's 12. And then we get the same figures, and it asks for the difference between the two, and so we got 6. All right, now let's go ahead and go on to 14. Each term of a certain sequence, boom, there's that word sequence. Almost always when I see that term, I get ready to start drawing blanks. All right, so each term of a certain sequence is greater than the term before it. The difference between any 2 consecutive terms in the sequence is always the same number. If the 3rd and 6th terms of the sequence, all right, so 1, 2, and I like to really actually just write out the word third and 6th term, 4th, 5th, 6th, are 17 and 77 respectively. What is the 7th, 8th term? Okay, so this is what we're looking for. Whenever you're dealing with a sequence of numbers, where the amount of change is the same between each one, which is what it says. The difference between any two consecutive terms, consecutive just means right next to each other. The difference between any two consecutive terms is always the same number. That means it's an arithmetic sequence. You don't have to know that name though. So whenever you have that though, you can say, hey, what's the difference between any two blanks? So what's 77 minus 17? It's 60, right? And then count how many jumps there are between those two terms. So there's 1 jump, 2 jump, 3 jumps. Divide that 3 into 60, and you'll have the amount that it jumps. So this is a plus 20. This is a plus 20. This is a plus 20. Go ahead and then extend that. Now add 40 to 77. And you'll have 117, and that's our answer. Whenever I have these kind of sequences on the SAT, there's almost always helps to just go ahead and draw out the blanks. And, oh, and by the way, and label, just so that you don't get confused, I actually really do write out 3rd and 6th and 8th. So I don't accidentally, while I'm going fast on the actual test, I don't accidentally confuse the top and bottom number. Okay, so 15. We have the absolute value of x minus 3 equals half. And what is the least value of x that satisfies the equation above? Okay, so there's several ways, I guess 2 main ways we can do this, but let me just show you my favorite way. Whenever you have an absolute value equation or inequality, you're really being given 2 equations or inequalities. By the way, inequalities are when it looks like this, just in case. So the first equation you're being given in this case is simply this with the absolute values bars taken off. So just x minus 3 equals half. That's equation number 1. Equation number 2, this is where there's two, I said there are 2 ways to do this. Equation number 2 is the same thing, except you make this negative. That's one way to do it. The other way is it's the same thing, except you make all this negative and keep that the same. So negative x plus 3 equals half. Either way you work it, it's going to be the same. Okay, so let's look at this side. We add 3 both sides. You get x is equal to 3.5. Let's go over here. Now we got a negative x. Now what is a half minus 3? We're going to get a negative 2.5. But then we need to multiply both sides by negative 1. So the least value that this thing can be is 2.5. Now, you can't grid 2.5 on the SAT answer sheet. If you go onto your answer sheet and you try to grid a 2, 1/2, they're going to think you mean 21 over 2. Don't do that. There are people who miss questions because of these kinds of issues. You need to convert that into either a decimal, so you either need to grid in a 2.5 or 2.5, or you need to turn it into a mixed number. So 2 times 2 is 4, plus 1 is 5, and that's 5 over 2. So you can grid in 5/2 or 2.5. Either one it's going to work. All right, let's go ahead. Ooh, number 16 is a fun one. A 4-digit integer WXYZ, in which W, X, Y, and Z each represent a different digit, is formed according to the following rules. I already have this out here. So rule number 1 says that X equals W plus Y plus Z. Rule number 2 is W equals Y plus 1. And rule number 3 is Z equals W minus 5. And then it asks, what is a 4-digit integer? Okay, what you don't want to do is try to turn this into a system of equations, the way you did back on number 3 and let's see, and one or two of the other ones I think we've done system of equation things where you plug one thing into the next. If you do that, you're going to waste a lot of valuable time plugging away at this question. This is called the time stopper question. So it's literally meant to kind of like stop you in your tracks and get you to burn too much time on this part of the section. So don't do that. And you can know right away. You can say, hey, could I turn this to a system of equations? But you go, wait, there are 4 unknowns, but there's only 3 equations. You'll never get there. Okay? Instead, you want to play a logic game with it. So we look at the rules and we recognize each of these have to be different, and you also got to recognize W can't be 0. If W is 0, and let's say who knows what the other ones are, that isn't a 4-digit integer anymore, right? It has to at least be 1, or otherwise this just becomes a 3-digit integer. And the problem says it has to be 4. Now the other ones can be 0, right? So like if W were 6, you know, Z could be, or Y could be 0, or, you know, X could be 0, or, sorry, they all have to be different. I'm not representing that. Or Z could be 0. All right, so now that we have those kind of observations in mind, let's just look at the rules here. Let's look at rule number 3. W can't be 0, so it has to be something more than that. If we add 5 to both sides, we don't know what Z is. Maybe Z is 0, but this tells us that W has to at least be greater than or equal to 5. Okay, so now that we have that, let's look at this other rule. If this thing is at least 5, we subtract 1 from it, then Y is going to be at least 4, right? Because 5 minus 1 is 4. And it can range all the way on up to, let's see, if this, it can't become 9, because that would, W would suddenly become 10, right? And you can't have, I mean, that wouldn't make sense, like a baby 10 inside this bigger set of numbers. So we can't have that. W can't be then bigger than 8, because if it's 9, then, let's see, let me just make sure this makes sense. If it's 9 and I add a 1 to it, this becomes a 10, and that's impossible. So it has to be at most an 8, and that would make W a 9 in that case. So we now know that Y is between 4 and 8, W is greater than 5. Now let's do this last rule we haven't looked at. X is equal to something at least 5, so this is at least greater than or equal to 5. Something in between 4 and 8, so let's just put greater than or equal to 4. So it could be 4, it could be 4, 5, 6, 7, or 8, plus some mystery value. All right, if this is a 5, and let's just guess this is a 4, this is already equal to 9. X is now equal to 9, just from their lowest values. That forces Z to be a 0. If it's anything else, like if it's a 1, this is going to be X is equal to 10. And again, we're going to have this contradiction where we have like a 10, though it's only a single digit. So Y, Z, and so we can't have that. So therefore, we've already found the values we need. So W is a 5, because let's just write this out again. WXYZ. Y is the 4. Z is the 0. And then Y is the 9. And there's our answer. 5,940. So let's go ahead. Let's see, we're on number 17 now. Two more. You're done with this section. So here comes, this thing is really not drawn to scale in the book or on the screen here. So note, figure, insert very, not drawn to scale. 17, the flag shown above is made of overlapping equilateral triangles ADF. So let's see, I didn't label these. This is ADF. It's an equilateral triangle, which means all the sides are the same, right? ADF and BCE, and this is BCE, and this is where they overlap, and so these sides are all the same. Okay, be careful here, by the way. You don't want to accidentally think that this segment is equal to that whole segment. So just remember that you're really dealing with this whole segment is equal to that whole segment. Okay. Because ribbon is to be sewn around the entire outer edge, it is necessary to know the perimeter of the flag. That kind of cracks me up. They want to give you a justification for why you're doing this problem. All right, if CD, DE, and EF each have length 10 inches, so CD is 10, DE is 10, EF is 10. What is the length in inches of the perimeter shown in bold, which is everything except the dotted lines? Let's be careful now. DE is 10, and D to F then is what? It's not 10. Here's a 10 here. It's 20. So the one side of this equilateral triangle is equal to 20. That looks like a 26, sorry, a 20. That means that this length here is 20 since it's equilateral. Now be careful. It's very easy to just be in a hurry, especially towards the end of the section, and just say this is equal to 20. But because they're overlapping like this, you only have 10 out there, half of the value. Same for here. We got a 10, and then over here we have our 20 from B to C. Now we're ready to add up this whole triangle. So we got C to D is 10, plus D to E is 10, plus E to F is 10, so that's 3 10s, plus we got a 20 and a 20, so 2 20s, and then plus we got a 10 and a 10, so 2 10s. All right, so we got a 30 plus a 40 plus a 20, and now we have the answer is going to be 90. And that is, did I miss in inches? So yeah, no, that's it. You just grid in your 90 and you're done. So let's go ahead and look at our last problem. So number 18, the graph above shows the function g, where g of x equals, here let's go ahead and write this out, g of x equals k times x plus 3 times x minus 3 for some constant k. If g of a minus 1.2 equals 0 and a is greater than 0, what is the value of a? Okay, we need to approach this problem conceptually. So remember all those times you factored polynomials, like x squared minus 9 or something. You've always set it equal to 0, and then you factor it away like that. And then you said, hey, x is equal to -3 or +3. Think about what you were actually doing when you said that. You're saying that this is when that function is equal to 0, when the function g of x is equal to 0 in this particular case. And remember, these g of x's are the same as y values. When y is 0, that means where does this function hit the x-axis? That's what you were finding out this whole time whenever you did that. And if you look at over here, a constant just means it's some number, and that number doesn't change the way a variable can. So k is some number multiplied by x plus 3, x minus 3. If k is some number, whatever, let's say it's 1,000, you're able to divide both sides by that 1,000. It cancels out, and 0 divided by anything other than 0 is equal to 0. And so now we have these two things that give us the roots. Roots meaning where this function hits the x-axis. Now that we kind of have that in mind, it actually makes the question rather simple to answer. They're telling us that this is equal to one of the roots. And so this thing should be equal to either of those values. Now, let's go ahead and find both. So a minus 1.2 is equal to a -3, and an a minus a 1.2 is equal to 3. Let's go ahead and add 1.2 both sides. This is a negative value, and they told us a has to be greater than 0, so we can just discard that right away. So we add 1.2 here, and we get a 4.2, and there's our answer. So a equals 4.2. You really just need to remember what the factors of a function mean. They essentially gave you an expression for one of the factors, and they showed you with this part what two of the factors could be. They constrained the answer, and that's why we have a 4.2. Okay, we could go over functions. You can go ahead and check out my video on my first video on the SAT, where and you can see the little links where I go over the definition of a function and things like that. But you know, just in case, now I'm starting to feel like I want to go over that right now. Let's just quickly go over functions here, so that there's hopefully a little bit more light shed on this problem. So I like to think of functions as being a box. And there's a funnel for the box up here, and a funnel right here. Here's my beautiful drawing here. So what goes into the box are x's, but in this case, this problem uses x's. So x's go into the box. Mysterious stuff happens. That mysterious stuff is defined as like essentially arithmetic, you know, multiplication, subtraction, division, raising things to powers. And in this case, the mysterious stuff is partially defined as x plus 3, k times x plus 3, x minus 3. And then what comes out are the function value g of x, which is also kind of like saying y values. All right, you put in x's, stuff happens, right? Stuff happens to the x, and it spits out a y. It's like a little machine. Let's even draw a little crank. You crank it up, and out come these things. One way to look at problem 18 is it's saying that, hey, we put in these x's, this is what happens, and what comes out are the g of x's, and we know from this, and from looking at that graph, that these factors, when they hit 0, when this spits out 0, the x that went in is either a -3 or a +3. That's what it's saying. When you put in a -3, this whole thing is going to become a 0. 0 multiplied by any number of factors is 0. If you put in a +3, same thing's going to happen here. That thing's going to become 0. And so no matter what, either x is going to spit out a g of x equals 0. Okay? We took that information and we said, hey, a minus 1.2 equals this, and it equals that. So it equals -3, and it equals the +3. Okay, and then from there we solve the same way. So this is kind of a little bit more about what's going on under the hood, so to speak, for number 18. Okay, so that's it for section 7, and best of luck on your SATs.